Okay, so this is the second video on linear programming. If you haven't watched the first one, I would go back and watch that. I walk you through the steps, and we do an example that it's a pretty similar example, but I'm going to go through this one a little more quickly. All right. So if you need to, go back and watch that video if you need to see the steps required for linear programming. All right. So again, we've got a pizza place here. They make $1.50 for small pizzas. They make $2.15 on large pizzas. On a typical Friday, the pizza place sells at least 80 smalls and at least 40 larges, but they've never sold more than 220 pizzas. Okay, so how many of each size pizza must be sold in order for this place to maximize profits? Okay, so just like we said before, steps 1 through 3 are all mental steps. We want to understand the problem. We want to define the objective. We want to define the constraints. We want to understand those, okay? Steps 4 through 8 are going to be where we actually write stuff out and solve the problem, okay? So step 4, like we said before, is define the variables. Again, I want to use X and Y, but if you want, you could say S for small pizza and L for large pizza. It's really up to you. But I'm going to use X and Y, okay? So X is small pizzas, Y is large pizzas, okay? Step 5 is write the objective function. We're wanting to maximize profits. So they earn $1.50 on each small, so that would be 1.5x. They earn $2.15 on each large, so this would be 2.15y. And we want to add those together. Again, remember, this is not an equation. This is not an inequality. This is just an algebraic expression. Step 6, we want to write and graph the constraints. Okay, this is where we read the problem and translate what we see into inequalities. So at least 80 smalls would be X is greater than or equal to 80. At least 40 larges, Y is greater than or equal to 40. And they've never sold more than, has never sold more than 220, okay? So when I add those two together, it's never been more than 220, so we're gonna say less than or equal to 220, all right? So now let's graph each of these inequalities. X is greater than or equal to 80. Oop. Okay. This is actually Y is greater than or equal to 40. Excuse me. Graph that one first. Okay, so we would be shading above this one. Okay. Now we're going to graph the X is greater than or equal to 80. Notice my scale here is 20. I should have touched on that sooner. X is greater than or equal to 80 will be right here. So we would shade in this area now. Okay. And then finally, X plus Y is less than or equal to 220. Well, my Y-intercept and my X-intercept are both going to be 220. So it's going to be this line right here, okay? And we would shade below that. So this triangular region right here is going to be our feasible region, okay? So we want to determine the vertices of that feasible region. Again, we need to think about our scale. So each grid line is 20 pizzas. So the first one, I'm going to go here. This would be 80, 40. All right. The second vertex of the triangle we're going to use is 180, 40 here. Okay. And the last one is going to be this vertex right here, which is at 80, 140. Okay. So those are the vertices I want to plug back in to my objective function. All right. So let's test those and we'll see which one is the largest. Okay. So let's try the first one. $1.50 times 80 smalls plus $2.15 times 40 larges gives me a total profit of $206 for the night. Okay, let's test the second combination here. $1.50 for 180 smalls plus $2.15 for 40 larges. It gives us a profit of $356. And then finally, we've got $1.50 times 80 smalls plus $2.15 times 140 larges, which gives me $421, okay? So $421 that night. So that's the combination that the pizza place needs to sell in order to maximize profits, okay? We want to sell 80 small pizzas and 140 larges, okay? So that's the linear programming process. If you have any questions, reach out.